Hey everybody, hope you guys had a great weekend. Just learned the other day that Governor DeSantis said that school is going to be closed for the remainder of the year. I guess that could be good news and bad news. The good news is, I guess the good news is that you won't have to see my ugly face for the rest of the year. Bad news is you're going to have to listen to my annoying voice on these videos for the rest of the year. But we're going to make do. Today's lesson, our last lesson was on geometric series, which was when we add up a geometric sequence. We also included adding up infinite geometric series. So today, and this was the formula that we used to add up an infinite geometric series, a1 over 1 minus r. This was the formula. So one cool thing that we can do that's like a real life example of an infinite geometric series are repeating decimals. Repeating decimals are actually an example of a real life infinite geometric series. Let's take, for example, this repeating decimal, 0.24242424 ... right? This is an infinite geometric series because the ... it goes on forever. I can actually write this number in this form, right? It's 24 times 0.01, which is 0.24, plus 24 times 0.01 to the second power, which is 0.0024, plus 24 times 0.01 to the third power, which is 0.000024, ... right? And if I add this, this, and this, I get this. And that keeps going, right? The next one will be to the fourth power, to the fifth power, and it keeps going. And that's how you keep getting more and more digits, right? So this number is actually an example of a real-life infinite geometric series, right? My first term, my a1 is 0.24, and the r, the sequence keeps multiplying by is this 0.01, right? This times 0.01 is this, times 0.01 is this. So my r is 0.01. So to figure out what 0.242424, infinitely is as a fraction, I can just plug into my formula. Just all I have to do is plug in a1 and r. Again, my a1 is the first two digits, 0.24, and r is 0.01. So if I plug those in, a1 is 0.24, r is 0.01, right? 1 minus 0.01 is 0.99. So I have 0.24 over 0.99. I can reduce this fraction, right? I can move each of the decimals 2 spots over to get 24 over 99. And then 24 over 99, if I divide by 3, I get 8 over 33. So 8 over 33, this fraction is 0.2424 repeating, right? So I was able to turn this repeating decimal into a fraction using this formula for infinite geometric series. So let's do another one. Let's do two examples. I want to do 0.333333 repeating. Now, some of you may already know what this is. All right, this is probably the most common one. You already might know what this is as a fraction, but let's figure it out. All I need to know is a1 and r. So a1 is the first one that before it repeats. So 0.3 is my a1. R, only one digit is repeating. So I put a little chart here. When one digit repeats itself, let me move this over. When one digit repeats itself, the r is 0.1. When two digits repeat itself, the r is 0.01. So like in the last example, 2 digits repeated itself, so the r was 0.01. But here only one digit, only the 3 is repeating itself. So r is going to be 0.1. R is 0.1. So now just plug into the formula. A1, which is 0.3, over 1 minus r, which is 0.1, right? So that's going to be 0.3 over 0.9. 1 minus 0.1 is 0.9. Move the decimal 1 spot over, that's 3/9. Reduce 3/9, and you get 1/3. 1/3. So a lot of you probably knew at the beginning that 0.3 repeating is the fraction 1/3. All right, let's do one more example. one more example. So I want to figure out 0.72727272. I want to know what this repeating decimal is as a fraction. So I need to know A1 and R. A1 is the first two digits before the repeating starts. So my A1 is 0.72. R, two digits repeating themselves. So R is 0.01. So plug in A1, 0.72 over 1 minus R, 0.01. So that's going to be 0.72 over 0.99, 0.72 over, move the decimals 2 spots over, that's 72 over 99. And I can divide by 9. Divide each of those by 9. 72 divided by 9 is 8. 99 divided by 9 is 11. 8 over 11. So this repeating decimal, 0.72, repeating itself, is the fraction 8 over 11. And I'm doing this because this number is a real-life example of a infinite geometric series. So I'm using the formula A1 over 1 minus R to turn the decimal into a fraction. Pretty easy lesson today. Hope all is well. If you have any questions, please reach out to me on Remind. If anyone wants a live lesson, one-on-one, I can accommodate you guys. Just please reach out to me and I can set it up. A few of you have done that already, and it's been great. So if you have questions, please ask me. You're not expected to do this on your own. I'm here to help you. Miss you guys. Talk to you soon.